Okay, in that lecture we can talk about the Mastercam 5-axis again. So you can see and the simple example of and designed by me. So I can easily and explain to you and how can we use the 5-axis process in Mastercam. So okay, let's and show, and with the backload simulation I'm gonna click on the backload simulation. As you can see that I used and the sum flat tool, so it means that of course that's kind of surface and I need to use 5-axis. And actually it is easy for me to create some toolpath and by using the 3-axis operations. But if you intend to use the flat tool, so it means that you need the 5-axis operations. So I created and like this toolpath. So you can see that I am using the different tool orientation here and to create that kind of toolpath. Okay, of course before that maybe and it will be better for us to explain a little bit how can we create some toolpath and of course and only using the 3-axis. Okay, let me show you that. So I'm gonna click on that curve and right mouse button to change my color. This is my curve 1. So maybe I can create curve 2. That's why I am using the wireframe, curve on an edge options, clicking on a surface, after that showing the edge, so I can be able to create my second curve. Okay, that's it. After that let's use right mouse button, mill toolpath, and maybe I can use the surface finish and blend toolpath. Okay, I'm clicking on that surface. After that I can use the blend options. This is my curve 1, this is my curve 2. I'm gonna click on OK button. After that of course I cannot use the flat end mill, so this is not possible for me. I'm gonna click on the ball nose ball toolpath with 10 millimeters. I'm gonna click OK button. Maybe I can write that feed rate and that cutting speed with that plunge feed rate with rapid retract. Okay, after that I can turn to retract position, can be 5 millimeters. It can be absolute, of course. I can use the feed plane 1 millimeter. So I don't want to leave any stock on the drive surface. I'm not selecting any check surface. So I'm using that type of tool offset. So I can turn to finish blend parameters. Okay, in that case I can write 2 millimeters. So I can use zigzag. So it means that I am using the along my curve with 3D. So I can focusing on the getting parameters. It can be optimized cut order. Maybe and it will be better for us to use smooth, and I can use that kind of arc like this. This is my arc angle and this is my arc tangent length to extend my toolpath. Okay, that's it. After that I can click on that button to calculate my toolpath. Okay, that's it. I can turn to that side and can copy or cut my toolpath and paste it here. Okay, when I click on that part you can see my extension like this and my radius and my entry extension here. That's all about 3-axis process. Okay, as you know that in the 5-axis operations, of course I am focusing on the 2.5 toolpath, and in that case if it is not possible and I can turn to the 3-axis. So this is not possible also, I can turn to I can turn to 5-axis. Okay, let's see what's happening. I'm gonna click on backdot simulation. I can cancel my holder, my movement. I'm gonna turn back to top view so I can easily see my toolpath like this. Okay, everything seems fine. So that's it. I created my 3-axis toolpath. So what is the difference between the 3-axis and 5-axis? Of course, in that case, I can be able to use the flat tool. So that's why I can use in the cut pattern parameters and maybe 3 or 5 millimeter step over to get my surface. Okay, so I'm gonna show you the tool orientation here like this, so it's perfect. Okay, how can I handle this? Okay, and I can select pattern and parallel toolpath. After that, of course, according to my toolpath type, I need to fill and cut pattern parameters. This is curves, so you can see that this is my curve. Okay, after that I need to select my drive surface. This is my drive surface. That's it. After that I can write my step over. After that, of course, tool axis control is quite important. When you're focusing on the tool axis control, I'm gonna click on output format as a 5-axis. This is my maximum and angel step. After that, I can select my tool axis control. My tool axis control and surface with tilt. So it means that my tool focusing only the surface normal. And of course, and according to my surface, also I can organize side tilt definition. And the side tilt definition, I'm gonna click on the dot parameters to cut direction at each contour. So it means that I can be able to calculate my tool axis according to my contour. And of course, it is included each step over. After that, approximate and by one vector. I'm gonna click on that one. So it means that I am not focusing on the all vector and according to my curve. I'm only selecting one vector. Of course, it is depends on our toolpath curve. So that's why I am selecting that one. So that's it. Okay, after that I can easily calculate it and my toolpath like this. So you can see in the simulation mode. So yeah, that's it. You can see that I can be able to create that kind of surface and with easy way. So this is also good for you to handle that kind of toolpath and in a short time. Okay, so that is the good example to explain toolpath type and parallel. Also, you can see that kind of operations. You can also click and select that kind of surface with that title. So you can organize your tool axis according to your curve, side curve, like that one. I can also select some surface. This is not necessary. So I can also click on some surface, but maybe I can also select some angle to organize it. So yeah, that's it. Okay, thank you very much for listening to me. And this is the parallel pattern 5-axis toolpath I try to explain to you. Okay, thank you very much for listening to me and have a nice day. And don't hesitate to ask me any question if you have any problem or any question. about manufacturing or other engineering perspective, and just try to ask me. After that I will try to do my best. Okay, thank you very much.